Hi friends, welcome back to More Math with Ms. Beck. Today we're talking about inequalities in triangles. Our objective today is to be able to understand that the sum of the length of any two sides of a triangle is greater than the length of the third side. The sum of the lengths of any two sides are greater than the length of the third side. Look at triangle ABC. Side AB has a length of 7 centimeters. Side BC has a length of 5 centimeters. And side AC has a length of 4 centimeters. If two sides together need to be greater than the third side, then look below at the formulas. Side AB together with side BC need to be greater than side AC. Likewise, side BC together with side CA need to be greater than side AB. And finally, side CA plus side AB together need to be greater than side BC. This is a rule of all triangles. Let's try a problem together. Look at triangle PQR. It has sides PQ equal to 8 centimeters, side QR equal to 10 centimeters, and side PR equal to 6 centimeters. PQ together with QR need to be greater than RP. So we insert the values that we know for the side lengths to check this out. Side PQ has a length of 8, so we replace those variables with the value 8. Side QR has a side equal to 10 centimeters, so we replace that variable with 10. Then we add them together to be 18, and 18 is greater than 6 centimeters, the length of side RP. Then we move on to add together two different sides. QR plus RP should be greater than PQ. So we insert the values for those sides. 10 plus 6 should be greater than 8. So we add together 10 plus 6 and get 16, and 16 is greater than 8. And then we try the remaining two sides to check to see if they're greater than the third side. Side RP plus side PQ should be greater than side QR. 6 plus 8 should be greater than 10. When we add together 6 plus 8, we get 14, and that is greater than 10. Therefore, this triangle is possible. It does, these sides will create a triangle. Let's practice this skill together. Do the given lengths form a triangle? Here are the given lengths of a possible triangle: 5, 6, and 7. We don't even really need to have that figure in front of us. However, sometimes it's helpful to draw a triangle and label the sides in order to see it better. We first put together the 5 and the 6, which is 11, and 11 is greater than that third side, 7. Next, we grab the second two. 6 plus 7 is 13, and 13 is greater than the value of 5. Then we grab the last value and the first value to try that combination. 7 plus 5 equals 12, and 12 is greater than 6. Therefore, this triangle can be formed. Don't forget, you must have all possible combinations be greater than the third side in order for it to be a triangle. Now it's your turn. Do the given lengths form a triangle? One side is 2 inches, another side is 4 inches, and the third side is 1 inch. Pause the video and try all the possible combinations to assure that any two sides added together are greater than the third side. When we add together the first combination, 2 plus 4, we get 6. 6 is greater than 1, that third side. Now we're going to try our next combination, 4 plus 1, which equals 5, and 5 is greater than that third side of 2. Our last combination, the 1 plus the 2, together equal 3. Is 3 greater than 4? Of course it's not. 3 is less than 4. Therefore, this triangle cannot be formed. It would look something like this. Now we're going to move on to another skill that's a little bit more challenging. We're going to try to find the possible length of a third side of a triangle given two other sides. The instructions read as this. The sides of triangle ABC are in whole centimeters, which, remind yourself, means whole numbers. There will be no fractions or decimals to these numbers. We are given that AB is equal to 11 centimeters and side BC is equal to 14 centimeters. However, look at side AC. We are being told that AC is greater than 20 centimeters. Now we're asked to find the possible lengths of AC in whole centimeters. What could AC possibly be equal to? We start by adding together sides AB plus BC. Well, AB has a value of 11 and BC has a value of 14. We put them together and we get 25. Let's go back here. It says that AC is greater than 20. So if AC is greater than 20 and these two sides together are 25, what do you think the possible values of AC could be? Well, AB plus BC need to be greater than AC. So if this is the greatest number, if these two together need to be greater than this, what are the possible values? The possible lengths of AC are 21, 22, 23, and 24. Remember, the length of AC is greater than 20. 21 is greater than 20, but less than 25, as is 22, 23, and 24. Let's practice this together. We are told that triangle XYZ is a triangle in which the length of side XY is equal to 11 inches, the length of side XZ is equal to 19 inches, and the length of side YZ is greater than 26 inches. All the while, we're going to keep in mind that the length of these two together need to be greater than this. We're asked to find the possible lengths of YZ in whole inches. So again, we first put together the sides we know, which are XY and XZ. XY has a value of 11 and XZ has a value of 19. Together they equal 30. And don't forget, this side needs to be greater than YZ. But YZ is greater than 26. Therefore, XY plus XZ is greater than YZ. 30 needs to be greater than YZ, or we could look at it as YZ has to be less than 30, but we know it's greater than 26. So what values are greater than 26 but less than 30? The possible lengths of YZ are 27, 28 and 29 inches. Again, you did a fabulous job today, but we always want to remember to first analyze the problem. We want to read carefully for understanding, which means we may need to go back several times to read again. And with problems like this, we want to work systematically. We want to make sure that we're doing everything the same every time and not missing a part so that we are doing the problem correctly. You've got this, friends. Work carefully and slowly and have a great time.